All right, this is lecture 12 of the course Electrical Systems in Agricultural and Biosystems Engineering. Previously, the discussion was on electrical safety in relation to the current topic to be discussed in this video, which is wiring. Again, safety is required because wiring in EB systems involves lives from the human occupants to the animals being contained. Okay. In the wire and cable world, there are many types available in the market, or they are commercially available, and they are dependent on the uses and applications because each would have would suit a specific need. In Figure 1, shown are the different wires and cables that are, well, just representative of the actual commercially available actual ones. And well, the sizing was discussed already in lecture 3. And in this lecture, focus would be on the uh, classifications of wires based on their ratings and properties, okay, or the characteristics that categorize them as such. That is a very important factor in the design because each helps the design of the wiring, okay, for the design to fulfill specific roles. And with new innovations, it is actually important to keep the this types of discussions as updated as can be because of innovations in the industry. And in the design, okay, of wires, one important aspect, okay, is insulation, okay, and it is because what? It's because of the uh, containment of the electricity, okay. It is important to look at the purpose of insulation, and from the root word insulate, okay, which means to keep things within, particularly the electricity. So it is a material that restricts the free flow of electric charges, or to have, okay, very little electric current passing through it, okay, even under the influence of electric fields, as with conductors, okay, metals, which the insulation now insulates, right? In the wire, okay, in the wire industry, okay, there are so-called solid conductors, and they tend to be hard to bend as they get bigger in size. Now, smaller strands of wire twisted together can equal the same effective um, area, okay, as a solid strand, and that is why there are also stranded wires. And the difference between the two, the solid and the stranded, is the bendability, okay. And again, the same effective area can carry the same amount of voltage and current across a conductor, and these are now determined by what? The wire gauge, okay, the wire gauge. So a wire gauge, the wire gauge, okay, it determines and classifies the size of wires in terms of the diameter and the area. And based on the computations on um, the current and voltage, okay, the ampere rating can also be provided based on this diameter and area. The bigger the wire, okay, the larger the ampere rating, okay. So the more electricity it can convey. This is shown in a summary table number 1, which is the metric and American wire gauge um, classification of wires. Okay, the American wire gauge, okay, is a nominal classification system, and as it goes down, as it goes down, the wire size increases, and likewise the ampere rating. Okay, here is a continuation of that table showing the metric size, okay, in millimeters squared, okay, the diameter in millimeters, the AWG, the diameter in inches, and the ampere rating. Okay. Notice the increase, okay, the nominal increase in the AWG, the decrease in the AWG as the metric size increases, and the ampere rating as well. Now, the AWG measurements, or the nominal classification, does not consider the insulation of the conductor. The higher the AWG number, again, the smaller the conductor. And the most common wire gauges, AWG wire gauges, are shown on the screen, from 14 to 2, okay, with two okay, two unit differences: 14, 12, 10, 8, 6, and 2. The 18 gauge is particularly usable in 10 ampere ratings, okay, for low voltage lighting and lamp cords. You have the 16 for 13 ampere light study extension cord, light duty extension cords. 14 gauge, 15 ampere light fixtures, lamps, lighting circuits. The 12 gauge for kitchen, bathroom, outdoor receptacles, and 120-volt air conditioners supporting 20 amperes. The 10 gauge, these are for electric clothes dryers, and 240-volt, okay, window air conditioners supporting 30 amperes. 20 amperes. The 30 amperes, sorry. The 6 gauge, 40 to 50 ampere cooking ranges, and lastly, the 4 gauge used for electric furnaces and large electric heaters, protected up to 60 amperes. Individually insulated wires typically are used for installation inside of conduits or flexible metal cables, and the coding system relates to the performance characteristics of the wire, okay, particularly the insulation. The most common types of wire used in residential construction are the THHN and the THWN. And here are the definitions of the letters, okay, specifications. So T means thermoplastic, which relates to the heat-resistant property of plastic, okay, used on wires. H for heat-resistant, up to 167 degrees Fahrenheit or 75 degrees Celsius. HH, okay, and an additional H meaning a higher heat resistance. That's up to 90 degrees Celsius. You have W for moisture resistance, okay, indicating moisture resistance, and that indicates wires suitable for damp and wet environments. And lastly, N for resistance to oil, okay, which means nylon coated. So oil includes petroleum products. Now there are non-metallic cables, and they're labeled as such: NMB, standard NM cable suitable for indoor use in dry locations. And there's the older version of NM, the NMB cable, and it's just labeled NM, meaning meaning without a B, and thus having a slightly lower temperature rating, okay, than the current NMB used commercially today. You have the UF, okay, underground feeder cable for outdoor exposure and direct burial in the ground. Then there's the service entrance cable, or SE. These are the outdoor rated cable for above ground use. And lastly, you have your cable for commonly used to bring power from the utility transformer, okay, from the utility transformer to the end user, okay, to a house, for example, and that's the USE, or the underground service entrance cable, okay, similar to SE, but just with the U, which means it's for underground, or um, rated for direct burial. Now, insulation also protects the equipment user, again, because the word insulation, it restricts the flow of current. Plastic is the most often used, okay, insulator, and actually it's the best. And there are many types of plastics depending on the chemical formula and structure. In this table 2, okay, listed are the different plastic types and the various material properties depending on their ability to resist physical and chemical agents. There is oxidation, heat, oil, water, flame, ozone, and even solar lighting. The different plastics are rated according to the resistance to action of these um, agents. Okay, so as shown at the bottom, we have O for outstanding, okay, for the highest rating, and the P for poor, okay, which is the lowest. And the different plastics are identified in the next slide. Okay, the different um, conventions. Okay, PVC, which is polyvinyl chloride, LDPE, low density polyethylene. Okay, it's shown in the next slide. But this is not complete. Okay, these are just the most common insulation materials for wires. So this is based on their chemical composition. Okay, these are the most common: PVC again, LDPE, HDP, which is just high density polyethylene. We have PP, polypropylene. Okay, um, and others are actually very specialized plastics, such as the CPE, the FEP Teflon, okay, fluorinated ethylene propylene. You have also the ATPE, ATFE, ethylene tetrafluoroethylene, and PTFE, the polytetrafluoroethylene. Right. Now, with this information, okay, based on the rating, okay, a certain cable would be able to match the required amperage. So it's best to look at the ampere rating, okay, to carry that the electricity, okay, because inside the home, okay, the usually the voltage is maintained at a certain level, and it's the ampere that changes uh, um, with regards to the applications. Okay, so thank you for listening, and I'll see you in the next lecture for the continuation of the course. Thank you for listening.